what we are going to do in this video is we are going to integrate, we are given this integral 16 secant cubed of x dx, and we are going to integrate it. So the first thing we want to do is we want to separate this. So this becomes the integral of 16 and then secant x times secant squared of x dx, and all I did is simplify it. But now, if you, I hope maybe you can see this already, but this is the integral. If you take the derivative of tangent, you get secant squared. So we'll be able to do integration by parts. And in case you don't remember, the integral of u dv is the same thing as uv minus the integral of v du. And what I just said, tangent is if you derive tangent, you get secant squared of x dx. So that's automatically going to be our dv term. So we have dv is equal to secant squared of x dx, and that means that v, what is what I just said, it's going to be tangent, because if you take the derivative of tangent, you're going to get secant squared of x. And now we can make our u term everything else. So that's going to be 16 secant x, and then when you take the derivative of that, you're going to get 16 secant x tangent x dx. And now what we can do is we can substitute in for this part right here. So I'll rewrite it. uv minus the integral of v du, and that becomes u, which is 16 secant x, and then v, which is tangent x, minus the integral of v, which is tangent x, and then du, which is 16 secant x tangent x. dx. So what we can do now is we can manipulate this function a little bit and simplify it. So when you multiply the tangent squared by the tangent squared, you get the integral of 16 secant x tangent squared of x dx. And if you remember your trig identities, and hopefully you do, you know that sine squared of x plus cosine squared of x is equal to 1. And when you divide both sides by cosine squared, you'll end up getting that this is tangent squared plus 1 is equal to secant squared, or tangent squared is equal to secant squared minus 1. And what we have now is we have two terms. We have this tangent squared and this tangent squared. So what we can do is we can substitute tangent squared for secant squared x minus 1. So let's do that. We get that, and then what is x, and what we can do again is we can simplify this even more. That simplifies into 16 secant when you're distributing, so 16 secant cubed of x minus 16 secant x dx. And what you can do again, if you want to simplify it even more, is now you can separate this into two integrals, and we're going to do that. So you're going to get, I don't like that integral sign. You're going to get 16 secant cubed of x dx minus the integral of 16 secant x dx. And all I did was separate it right there. But that's only the second half of our original integral. We still have the 16 secant x tangent x part. So let's add that in there. Now we have 16 secant x tangent x. What we can do, this is before I go on, this is, it's like this, because this is technically in parentheses, and when you separate this, you're going to be distributing the negative sign into it. So this becomes, let's rewrite the whole entire thing, 16 secant x tangent x minus the integral of 16 secant squared of x, secant cubed of x, sorry. I don't know if I said that before. I might have. 16 secant cubed of x dx plus the integral of 16x dx, plus the integral of 16 secant x dx. And what we previously learned is that the integral of secant x, because this is a constant, so that's going to come out here, but this becomes, I'll do it in a different color. I'm doing white. Whoops, you don't need that anymore. It becomes 16. The 16 comes out because it's a constant, and then the integral of secant x is actually the natural log of the absolute value of secant x plus tangent x. So then we now have this term which we just integrated. We have this term which we are yet to integrate, and for good reason. And now we have the UV term from the beginning. And if you remember what our original integral was, the integral of 16 secant cubed of x dx. And amazingly enough, that's the same exact term as this one. So I wonder if I can fit this into one line. This is just coming down here. I'm going to write this right here. Plus 16 ln of secant x plus tangent x minus the integral of 16 secant cubed of x dx. And because these two terms are the exact same thing, we can technically just add them together, which is cool. So you get 2 times the integral and then that equals all of this nonsense right here. So that I'm not going to write it again. It just comes down. But what we can do now is you can divide everything by 2. So we divide by 2, you're going to divide by 2 and divide by 2, and then you're going to have the answer to your integral. So you're going to have 16, the integral of 16 secant cubed x dx is equal to 8 secant tangent plus 8 times the natural log of secant x plus tangent, and then plus your wonderful constant c.